894 all possible full binary tree. So we are given a number of n, and we need to return a list of all possible full binary tree with n node. So the full binary tree is a binary tree where each node has exactly 0 or 2 children. Yeah, so this is an example of 7 node. As we can see, it meets the condition of a full binary tree. So for each node, there are only 0 or 2 children. For this node, it has 2 children, and for this node, it has 0 children. Let me first explain it in the whiteboard, and then go to the code editor to finish the coding. So for example, we're going to use the example of n equal to 7 if we only have 7 nodes. So if it has only 1 node, so it meets the condition because for 1 node, it has 0 children. Yeah, and for 3 node, so for the root node, it has 2 children. So there's only 1 for 1 node and 3 node. So I use for 1 node, I will use A to represent it. Yeah, and for 3 node, I will use B to represent it. Yeah, because I will later on, I'm gonna use these characters to represent the combinations of different nodes. Yeah, so for 5 nodes, according to the example, we have 2 different combinations. Yeah, we can prepare a root node first, and then from the left side, we're gonna prepare a B, and from the right side, we're gonna prepare A. And similarly, this is the root node. From the left side, we're gonna prepare A, and from the right side, we're gonna prepare B. Yeah, and this one gonna be B and A with the root node. Yeah, according to this kind of checking, basically we know for the final result, it's gonna be combined with a left side and right side. So the left side is also with odd numbers of nodes, and the right side is also odd numbers of nodes. And the root node, of course, it is 1. 1 is also an odd number. Yeah, so everything inside, it will always be odd numbers. There will be no even numbers. Yeah, if it is even numbers, it cannot be a result. Yeah, for example, the left side can never be an even number of nodes, and also for the right side. So according to this kind of pattern, if we are going to calculate the number of 7 nodes, so how we gonna check? So for the when n equals to 7, for the left side, we're gonna prepare an array. So inside of the array, it will store the root node for each of the combinations. So for example, this is from the left side. And from the right side, there will be another array. But how can we get the left side array and the right side array? So we're gonna use a recursive function to check for the left side and the right side. Yeah. So the boundary condition is if there is n equals to 1, if there is only 1 node, so what are we gonna return? So we're gonna return an array. Yeah, so we're gonna return an array of A. So we're gonna return, this is an array inside, it's gonna be A. So we're gonna return an array of A if there's only 1 node. Yeah, if there are 3 nodes, what are we gonna do? If n equals to 3, so we're gonna return a node of B, right? Because there's only 1 combination of 3 nodes, so it is B. Yeah. So what about if there are 5 nodes? What are we gonna return? As you can see, this is a C1 and this is a C2. So if n equals to 5, we're gonna return an array of C1 and C2. C1 and C2 are different combinations of 5 nodes. Yeah. Now we have 7 nodes. So inside, from the left side, we're gonna prepare an array, and from the right side, we're gonna prepare another array. So how many combinations? Yeah, let's check. So for the left side, let's prepare. If there's only 1 node from the left side, so it means from the left side, it is A, right? And what about the right side? So in the right side, it must have 5 nodes. Yeah, because the root is 1 node. So in total, there are 7. So from the left side, there's 1 node, it is A. And from the right side, it must have n equal to 5 node. So from the right side, it must be gonna be C1 and C2. So this is one combination. So from the left side, it is A, and the right side, it is C1, C2. So currently, the result is 2. So how many combinations? There are 2. Yeah. Now we're gonna check the next one. We're gonna delete this one. So for the next one, what about if we have 3 nodes? So for the left side, we're gonna have a B. And what about the right side? In the right side array, so we're gonna have another B, because in total there are 7 nodes. So 3 plus 3, it is 7. We're gonna have a B. Yeah. So what about the combinations? So the combination is only 1, because B, this is the root node. The left side is B, and the right side is also B. So there's only 1 combination. So currently, the result gonna be updated to 3. Now we're gonna check for the n equal to 5 for the left side. So it's gonna be C1 and C2 for the left side. And for the right side, it must be n equal to 1. It is A. Yeah. So how many combinations? So it's gonna be the root node with the C1 with the A. Yeah, this is the C1, and the root node with the C2 and A. Yeah. So there are only 2 combinations. So we're gonna plus a 2. It's gonna be 5. So finally, we're gonna return this 5. Yeah. So the boundary condition is when n equals to 1, we're gonna return this kind of root node. It's gonna be inside an array, and it's gonna be the root node A. And then we're gonna use the recursive function to check the left side and the right side. Finally, we're gonna combine with the left side and the right side to check how many combinations one by one. And finally, we're gonna return the final result array. Actually, this result would be a final result array. Yeah, because we're gonna prepare a result array, and inside we're gonna put everything inside. Yeah. Now let me go to the code editor to finish the coding for this one. Yeah. Now let's check the conditions. We're gonna use n equal to 7 as an example. So if n equal to 1, it means there's only 1 node. So we're gonna return just inside array, it's gonna be a tree node. We don't need to initialize to be 0, because it is by default the value is 0. So we can prepare a tree node like this. Now we're gonna use an enumerator for check how many combinations. We're gonna use I for I in range. Yeah, because there's only odd numbers for the left side and the right side, so we can use 1 to n, and the distance is 2 for each of the next number. Yeah, so it means when n equals to 3, this I can only be 1. Yeah. Now let's check the left side and the right side. So for L in self dot all possible full binary tree for the left side, so it's gonna be I. And then for R in self dot all possible binary tree, so here it's gonna be the number of n minus I minus 1. This I is for the left side. We're gonna minus the left side. This 1 is the root. So there's only 1 root. So we're gonna minus this 1 for the left side and the right side. Yeah, so let's check for n equals to 3. So for the I should be 1. So for the left side, it's gonna be all possible full binary tree 1. And for the right side, it's gonna still be 1. Because 3 minus 1 is still 1, so it's gonna be have a combination only like it's gonna have a combination only like this, like this B, like the condition of B only have a 3 node. Now let's put the left side and the right side into the result. And for this L, inside of the L, it's gonna be an array. Inside of the array, it's gonna be a number of tree node for the root node of the tree. For the R, it's gonna be an array of the right side for the root node. Inside of the R, it's gonna be an array of root node. So we need to combine. So result should append the root. Yeah. Now let's prepare the root. The root will be a tree. So inside of the tree node, for the first value, by default, it's gonna be 0. Yeah. But for this line, I'm gonna use L and R. Yeah. If I were to save 2 lines of code, yeah, normally I need to use root equal to tree node and root dot left and root dot right equal to L and R. But I can also use 1 line of code to represent 3 lines of code. Yeah. So this is the value. We have to prepare a value 0 and L and R. You cannot only use L and R because the data structure of the tree node, the first value is 0 and then left and right. So you have to prepare a 0, L and R for the root and also for the left side and the right side. And then you can put the root into the result. But before that, you need to initialize a result array. It's going to be an empty array. So finally, we need to return this result. Yeah. Now let's run it to check if it works. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed all the testing cases, but it's pretty slow. It is 5% of all submissions. Yeah. Now let's try to optimize a little bit because this is a 3DP problem. I mean, while we are calculating the node of 7, we can use the previous value. For example, n equals to 3 and 5. It's going to be stored inside the memory. So we can use a cache to store the values for the sub-problem. We can use a cache. Now let me submit it to check if it can improve the speed a little bit. Yeah, as you can see, it improved to be 66% of all submissions. Yeah. Now let's analyze the time complexity. If without cache, basically we're gonna use a one for loop, and inside it's gonna be the recursive function for the left side and the right side. Yeah, it's really difficult to calculate, but approximately it's gonna be n times 2 to the power of n. Yeah, that is why it is so slow. But while we are using the cache, so every number will be stored inside the memory. So this is just one loop. This is on. For the left side, the length of the array it can be n, and for the right side it can also be n. Yeah. So if we use cache, so the time complexity will be n cubic. Yeah. Yeah, but this is just my analysis of the time complexity because the time complexity is really difficult to analyze for such a problem. Thank you for watching. See you next time.